Next, let's study the fundamental trigonometric identities. We call them fundamental trigonometric identities because they do not depend on any other trigonometric formulas. And remember what identities are. Identities are formulas or equations of the angle theta which are valid for all values of theta. So therefore, fundamental trigonometric identities are the three basic formulas which are valid for all values of theta, and they do not depend on any other trigonometric formulas. We derive them directly from Pythagoras theorem. So consider triangle ABC right angled at B, and C is the acute angle theta that we are considering. So therefore, if we have that, and then by Pythagoras theorem we get AB square plus BC square equals AC square, and thus dividing both sides by AC square, we will get the first fundamental trigonometric identity, that is sine square theta plus cos square theta is equal to 1. Dividing the two sides by AB, we will get cosec square theta is equal to 1 plus cot square theta, and dividing both sides of this equation by AB square, that is, we will get the second fundamental trigonometric identity, that is sec square theta is equal to 1 plus tan square theta. So basically the fundamental trigonometric identities are obtained by first applying the Pythagoras theorem and dividing by AC square to obtain the first one, dividing by AB square to obtain the second identity, which is sec square theta is equal to 1 plus tan square theta, and by dividing by BC square from both sides, we get cosec square theta is equal to 1 plus cot square theta. So these are the three most important identities in trigonometry, and since we have learnt it last year, it should not be difficult to remember. However, one should remember their rearrangements, and from the first rearrangement, we'll get many times sine theta as, or sine square theta as 1 minus cos square theta, cos square theta as 1 minus sine square theta. Similarly, sec square theta minus 1 equals tan square theta, which gives us also sec square theta minus tan square theta equals 1, which gives sec theta minus tan theta times sec theta plus tan theta is equal to 1 as well. Similarly, you will get the same results for the third identity, which is cosec square theta is equal to 1 plus cot square theta. Now let's look at a very basic example on this, which is quite often a part of your 10th standard syllabus. Find the value of the expression sin x plus cosec x the whole square plus cos x plus sec x the whole square minus tan square x minus cot square x. So therefore, the options given are 1, 7 and 9. Therefore, what we have to do is we just have to simply expand this expression and simplify it out and apply the identities wherever applicable. So sin x, so the expression is equal to sin square x plus 2 times sin x cosec x plus cosec square x plus cos square x plus 2 times cos x sec x plus sec square x minus tan square x minus cot square x. Sin square x plus cos square x gives us 1. Sin x times cosec x is also 1 because sin x is the inverse of cosec x and vice versa. So 2 times sin x cosec x is just 2 plus. Cosec square x, can I write it as 1 plus cot square x? Yes. Why do I write that? Because I know that there is a minus cot square x which will cancel it. So 1 plus cot square x. Cos square x has gone. Cos x times sec x is just 1 again. So you have that. Plus sec square x can again be written as 1 plus tan square x. Minus tan square x minus cot square x. So we have 1 plus 2 plus 1, which is 4, plus 2, which is 6, plus 1, which is 7. So option B is the answer to this question.